So, are ready to take notes? So take notes and then practice and then another practice. So 2 practices. One what we do and then a new one. Okay, the first topic will be called the data tables. Did you get a chance to look at the videos, the distributions and hypothesis testing from statistics? It's okay, we'll just go over that when we do the problem. Oh, you've done statistics, okay. Oh, that's good. So over there, you have to do a lot of calculations. Here we see how to do it in one click. It'll be way easier. But the first topic will be data tables. And data tables lives in the data tab on the top. And if you remember in what if analysis, we did this in the previous class. We did goal seek, but today we'll do data tables. So it belongs to the same tab, what if analysis, but now we'll do data tables. Right, so the first question is in this box, from this list, do data validation here. So who remembers, how do we do data validation? Which one was it? This one. Yeah, this drop down, data validation. This, very good. And the source is you select. Very good. Okay. So now if you see you have a drop down. Right, this question number 1. Question number 2 is in this cell here, which is B9. Write a formula which calculates the final price after the discount. So for example, right, so the question is you're buying 10 quantities of something which is priced at 25 pounds and there's a 10% discount on it. You're buying something for 25 pounds, 10 quantity, 10% discount. So here write a formula that calculates the final price. So what should be the formula? Think about it. So you calculate the price and subtract the discount amount. So first calculate the price. How do we calculate the price? So this times, right, that's the price. Now minus the discount. This times this times this. Make sense? That's the final price of your purchase. And press enter. So now if you change this one to 5%, automatically the value should change. If you change it to 20%, the value should change. Right, that's question number 2. Question number 3 now is you want to see all of the values together in a data table. For example, if the price was 25 and the quantity was 5, what should be the final price here if the discount was 20%? If the price was 100 pounds and you buy 15 of that quantity, what should be the final price? That should come here. So you want all possible scenarios to be listed in a table. depending on this formula here. Is the question clear? What are we trying to do? We're trying to list all possible scenarios. So this is what you do. You do these two steps first, and then in step 3, you select the entire selection, including the formula here. So you start from the formula and select your entire table. Then go to data on the top. Go to what if analysis. And data tables. A new window opens up. In this box here, you have to input the row input cell. So what is in rows? We have the price, which is in. So in here, even though it's in columns, all of them are in a single row. So in here, from our original box, we click on price. In the original where you use the formula. And in the second one, we look at the column, which is quantity. And in the original formula, we select quantity. So now look what happens. All you have to do is OK, and the entire table gets filled just like that. Pretty cool if you think about it. So if you get 150 and 10 quantity, the discounted final value will be 1200 if the discount is 20%. If you change this to 5%, all values should change. Right? It's pretty simple, but very useful. Right, it's pretty simple. When you practice, you'll have to do the same thing for PMT. PMT, yeah. So if you don't remember, you'll have to look at the video. Yeah, so it is. PMT, we did it in the previous class. If you don't remember, just take a look at the video. There's a video for it. Yeah, the payments per month for the mortgage. All right, next topic will be the binomial distribution. Okay, so for binomial distribution, you need two things. You need the total number of trials, which will be denoted by n. And you need the probability of success for a certain event. That will be denoted by small p. Right, once again, n will be the total number of trials and p will be the probability of success. So now read this problem and tell me what is n and what is small p. Yeah, very good. N is 6 because he has a total of 6 corporations and discovers that the IRS audits, that's your P. When that happens, you should know that you have to use the binomial distribution. And then we'll have to answer these questions based on the distribution. So now we'll see how to generate the distribution in Excel. That's the next question. How to generate the entire distribution in Excel. Right, so N is how much? 6. And P is 0.48, right? 0.48, 48%. 40.8%. So 0.408. So now X will be the question that the problem is asking. For example, 2 or more will be your X. Exactly 5 will be your X. Whatever you want to find will be the value of X. So now to get the distribution, what we do is we start always at 0. Start taking notes. I'm recording it, okay? So you can take a look. Yeah. Okay, always start at 0 and go up till the value of N. So you do 0, 1, 2, just select and drag it down. So you start at 0 and go till the value of N, which is 6. If it was 10, you would go till 10 and so on. And the capital P of X will be denoted by probability of X. N is the total number of trials in your question, or the total number of companies, like in this case, and small p will be the probability of success. So for example, in this one, N is 6 and P is 40.8%. Trials, or the total number of probability of success. And when you have these two in the problem, you should know that you will have to use the binomial distribution. All right, this is how you do. You say equals, and you press BINOM, the first one, binom dot distribution. Right, the first thing number will be your X. So you click on X. Then you put a comma. The second thing is the total number of trials. What do you think that is? And very good. So you click on 6. Now, will the total number of trials be the same for all of them? When you drag it down? When I drag this down, will N be the same? Yeah or no? Yes, right? So if something is same for all, what do? We them. So we fix it. Comma. And here we will select false. the last one. If you do cumulative, it will keep adding the probabilities at each step, which we don't want. We want individual probabilities. So false. And then close the bracket. If you do true, then at each step it will add the previous one, which we don't want. We want individual probabilities for 0, 1, 2, 3, and so on. And press enter. And then all you have to do is drag this down. Now make a note to check if you're doing your work correctly. The sum of this column should always be equal to what? 1. Very good. Make a note. The sum has to be 1. Only then you're doing it correctly. Because the total probability is always 100%. So once you have this, it's pretty simple to answer any questions of probability. So just make a table like this for each question, make a table like this. So what is the value of x here in the first one? 2 or, so it means it could be 2, 3, 4, 5, and 6. N is 6, we know that, and this is 0. Okay, 40.8%. So now how do we get the px here for 2 or more? We just go in the other one. You say equals and go in the other one. And 2 or more means the sum of these 4. Close and enter. Sum of, and then you go to the other one and select from B6 to B10. So look at that. If you make this into a percentage, it's nearly 78%. So what does that mean? There is a 78% chance that there is 2 or more of his companies will be audited by the IRS. Does that make sense? Well, let's do one more, then you can finish the rest. Let's do C. So make another table like this, similar when you practice. Call it C. Make a similar table. This is how much 3 or less. Right, what should be the formula here? The sum of 3 or less. So it could be 0, 1, 2, 3. So 0, 1, 2, and 3. Close and. So there's an 80% chance, even a higher chance that 3 or less will be audited. Make sense? No? Which part? How do we get that? Yeah. So this one says 3 or less for x. So it means in your distribution, the probability of 0 plus 1 plus 2 plus 3, that's 3 or less. If it said exactly 5, then it's that one. How did I add? the sum formula. You equal sum and then go to that page and select the.
Did you do the same?
Yeah, we did the same sum here, but different. 2 or more means 2, 3, 4, 5, 6. Yeah, 2 or more. 2, 3, 4, 5, and 6. Because the total is 6. And if you say 2 or more, 2, 3, 4, 5, 6. All right, let's do D. You also have to find the variance, standard deviation, and the expected value. All right, the formula for the variance is N times P. Does anyone know N times P times 1 minus P? So let's do this. It's N times P times 1 minus P. So that's the variance in your spread. It means that's how spread your events are. The expected value is the same as the mean. Just make a note. Expected value is the same as the mean or the average. And the formula for the mean of binomial distribution is N times P. Just N times P. So all you have to do is this times that. That's the expected value. It means he should expect around 2.5 of his companies to be audited. That's the expected value in this experiment.
So
Yeah.
what's the EV?
Expected value. Expected value, yeah. And the standard deviation, does anyone remember the formula? Is SD is standard deviation. It's the square root of the variance. So you say SQRT bracket variance. And enter. So the square root of the variance is the standard deviation.
You put
SQRT, that's square root of the variance. All right, so that's binomial distribution. There's another distribution which is called as Poisson distribution, which is the same as binomial. But in this example, you don't know N, you don't know P. The only thing you know is the average or the rate. Once again, the only thing you know is the average or the rate in a given time period. If you read the first line here, tell me what is the average or the rate in this problem? 8 per week. So it's given the average and the time period. This is a notification that you have to use Poisson distribution. So let's see how do you make a Poisson distribution here. Right, so the mean here is 8. And for this problem, you have to go quite a long list for n. So you keep going till you get zeros for probability. Let's try till 16 and see if we get zeros. Because we don't know what n is here, so we don't know when to stop. But just make a note, if you're reading a book, the mean will also be called as lambda. The symbol, if you remember, the lambda symbol. Inverted A, like an inverted A. Maybe let me show you what is lambda. The symbol here is lambda, yeah? Look at that. That's the symbol for mean in a Poisson distribution. All right, let's see how to do this. Pretty simple. All you have to do is equals Poisson dot distribution. Same thing. The first thing is so you click on X. Do we fix it? No. Comma. What is the mean? 8 and fix. Comma, true or false? False. Close and enter. So now keep going till you get zeros. So we still don't get zeros, so we'll have to increase our reach here. Right, so looks when the E's come in, it means you're pretty close to zero. So till 20 is okay. But every problem you'll have to check till what point you have to go. If something in the E comes up, it means that's very close to zero. You can just stop before it. It means there is no chances that these probabilities will happen. They're like zero probability chances. Yeah. Yeah. First you click on the X, then the mean, fix, and then false. False, yeah, because we want individual probabilities, not addition of each probability.
So what should that?
So it will add it. So here you should get 0.0027 plus 0.3 and so on. Right, once you have this, you can answer any question. Let's do the first one. What is the probability that 2 accidents will occur during the next work week? So what is X here? 2. The mean is 8. And the probability is, you go back here. Do we need to add anything? Just 2, because it said exactly 2. If it says at most 3, 0, 1, 2, 3. In that case, you'll have to add 0, 1, 2, and 3. So I think you can do that when you practice. At least 4 means 4, 5, 6 all the way down. So it'll be a big addition. Right, the variance for a Poisson distribution is the same as the mean. Pretty simple. So it is also 8. And the standard deviation is always the square root of the mean variance. So now what is the meaning of this? They should expect a difference of around 3 accidents per week. So for example, if 7 happens today, this week, the next week it can either be 4 or 10. That's the meaning of standard deviation. That's the average distance between each week. Yes or no for these two, binomial and Poisson? All right, let's move on. All right, the next thing will be called hypothesis testing in Excel. If you don't remember this, let's just go through it. Step 1 for hypothesis testing is you find the H0 and H1. What does H0? Have you done statistics? Okay. What does H0 stand for? Very good. Null hypothesis. Hypothesis. And what does H1 stand for? The alternate hypothesis. All right, now make a note in your problem. The null hypothesis is always the one which has an equal to it. So the problem says certain thing is equal to or bigger than or equal to something, that will be your null hypothesis. And the alternate to that will be your alternate hypothesis. So in this, so whatever is the equal to in your problem will be your null hypothesis. So for example, if a problem says the salary is bigger than or equal to something, when the equal to comes in, that becomes your null hypothesis. And if it just says strictly bigger, that is your alternate hypothesis, or strictly less than. Right, so in this case, what is your null hypothesis? So the alternate hypothesis, so is there an equal to in here? It's significantly greater. If this was greater than or equal to, then this would become your null hypothesis. So in this case, bigger than 30 is your alternate hypothesis. And less than or equal to 30 is your null hypothesis. Can you guys see it, or should I zoom in? Let me zoom in. All right, step 2, what you'll have to do is list the data values here. So this is a little bit of manual work, 46, 38, 31, 45. Just gonna list this. Right, let's call this group A, yeah? Now make a note, if in your hypothesis testing, if there's only a single group, you will have to make a dummy group next to it. This is only for Excel, not when you're doing the actual calculation by hand. because Excel can only do 2 samples. This is just 1 sample. So whenever you have just 1 sample, you'll have to make a dummy sample and just add 0 zeros to it. So in this problem, there's only 1 sample, right? When that happens, you'll have to make a dummy sample next to it and enter 0 0 in it, couple of zeros at least. Now make a note, this is just for Excel, not when you're actually calculating, you don't need this. Once you have this much, you need the data analysis pack. So the next question is data analysis pack. The short form is DAP. DAP. Now it lives in the data tab. If you don't see it in the data tab at the end, you will have to install it. So write down the steps to install the DAP if you don't see it. Write it down. The steps to install DAP if you don't see it. All right, you go to File on the top. If you remember this, you go to Options here. And on the left here, you go to Add-ins. And in here, you click on the Analysis Tool Pack. And at the bottom here, you click on Go. And then tick the Analysis Tool Pack and do OK. Then at the end,
So can you start again, please? Sorry.
you go to File,
Good.
Options, Add-ins,
Where's options?
at the bottom. Then you click on the Analysis Tool Pack and click on Go. Click on Add-ins here. And the Analysis Tool Pack and Go. And you take the Analysis Tool Pack and do OK. Click on the Analysis Tool Pack and do OK. Once you do that, you should be able to see the data analysis at the end. Yeah, is it okay? All right, so then click on the Data Analysis tab or the button, and a new thing opens up. Right, for hypothesis testing, you scroll down and you will go to t-test, to sample assuming unequal variances. T-test, to sample assuming unequal variances. That's the reason why we created a second sample, because there is no option for a single sample. And in general, 2 sample data have unequal variances. You can't assume they're equal. It's rarely that thing happens. All right, then click on OK. Right, so the second last one from the bottom, yeah? T-test, 2 sample assuming unequal variances. Click on OK. Then you just enter the things. The first one is variable 1 range. You select the first sample, including the labels. Yeah. And the second one, you select the second sample, including the labels. And then tick on labels. And in this box here, you enter the claim. What was the claim here? If you look at the problem, greater than or less than 30. So the difference between the two we are assuming is 30. So whatever the claim value is will go here. And then in the output range, click on the output range. And in that box, say where do you want the output. And once you do OK, the entire output will come here. So let's hope it works. Look at that. The output is right here. Right, the dummy is just dummy. You can delete it if you want, or keep it. But the main value you want to look at here is the p-value one tail. Right, so this is what you want to look at. Give that a different color. So now who remembers how do you find the conclusion? Conclusion. Does anyone remember from statistics? Oh, maybe I forgot to show you one thing. Hold on. Right, this value of alpha, this is very important. This is called the level of significance, alpha. And in general, we'll keep that at 0.05. So don't change this value here, alpha. It's called the level of significance. So how do you find the conclusion? This is how you find the conclusion. If the p-value is less than alpha, you reject the null hypothesis. So what is the p-value here? 0.00579. And what is the value of alpha? 0.05. So which one is bigger? So this guy is less than, right? So the p is less than alpha. So our conclusion in this case is we reject the null hypothesis. What does that mean? So we accept the fact that the salary per hour of recent graduates is actually bigger than $30 because we're rejecting the null, we're accepting the alternate hypothesis. So in this, we have to write down, we say, we accept that the salary per hour of recent graduates, write down the answer in words, is higher than 30 pounds per hour. Make sense? This is how you will do hypothesis testing with one sample. Is higher, yeah, not if. Okay, now what do you do if you have two samples, right? This was one sample. So the next problem will be two samples. So now read the problem. Tell me what is H0, what is H1. So whatever is equal is your null hypothesis. So the null hypothesis are that the means are equal, not equal. Yeah. And then you do the same thing, list the items of two samples. And the only difference is in the hypothesized mean difference, you put a 0 there because only when they are equal, the difference is 0. So like we put the 30 there, you put a 0 here. And make a note in the output, you will look at the two-tailed test when there is two samples, two-tailed test. Yeah? Because we're assuming equal, not equal. There's two possibilities, could be higher or could be lower. So you have to look at two-tailed when you're doing two samples. Does that make sense what I'm saying? So over here we looked at one-tailed because there's only one possibility here. But when you're doing equal, not equal, there is two possibilities. It could be higher or lower. So in that case, you'll have to look at two-tailed and do the same thing, which I think you can try. Make sense? You want to do it?
Yeah.
All right, let's do it. I'll put this on Blackboard. Let me stop recording.